trinitrotoluene, commonly known as TNT, is a highly stable explosive chemical used in everything from bombs to industry to mining. It was originally invented in 1863 by German chemist Julius Wilbrand, intended to be a yellow dye. It was several years before it was realized to be an excellent explosive because it was so difficult to detonate. Prior to its invention, most explosive chemicals, such as dynamite and nitroglycerin, were highly volatile, with the slightest bump setting them off. TNT can be heated to over 200 degrees Celsius, molded into different shapes, and does not interact with water, yet can only be detonated with a pressure wave from an explosive booster. Despite being hard to activate, TNT has an incredibly high explosive yield of over 4,600 megajoules per kilogram and a detonation velocity of over 6,500 meters per second. This combination of stability and power makes TNT one of the most common explosives used in industry today. So much so that for a long period of time, the strength of all explosives was measured in the weight of its equivalent TNT. TNT's chemical formula is C7H5N3O6, comprised of a benzene ring of 6 carbons in a hexagon shape and 4 attachments, 3 nitrite anions and a methylene cation. In total, it has 7 carbon atoms, each with electron configuration helium plus 2s2 and 2p2, 5 hydrogen atoms, each with electron configuration 1s1, 3 nitrogen atoms, each with electron configuration helium plus 2s2 and 2p3, and 6 oxygen atoms, each with electron configuration helium 2s2 and 2p4. TNT is made from toluene, which consists of a benzene ring and a methylene cation attachment. To create TNT, toluene is nitrated 3 times with different acids, each time adding a nitrite anion. The benzene ring makes TNT exceptionally stable, so it is easy to mold and manufacture safely, while the nitrite anions make it incredibly volatile when exposed to extreme conditions. TNT has a melting point of 80 degrees Celsius. There are 2 main things that affect a molecule's melting point: symmetry and complexity. When molecules are more symmetric and more complex, they have a lower melting point. TNT is very complex and relatively symmetric, so its melting point is low compared to other molecules of its size. All told, trinitrotoluene has been and is an incredibly important explosive that has properties perfect for military-grade use. Though it is slowly becoming replaced by plastic explosives like C4 and RDX, it will always be known for its historical significance. Thanks for watching.